So we've got a pulley system here and it's on an inclined plane. Now the incline is given an angle of alpha, and all we know from alpha is the tangent of alpha is 3/4. And on this plane there is some friction on it which is given as mu, which has a coefficient value of 0.25. Now on the pulley system we've got this block at A which is 2m kilos, and at B it weighs 4m kilos. That's all we're told. And there's going to be some tension in the string which points towards the pulley, and block B is h meters off the ground. Now what we want to do is we want to calculate these 5 things. In the first instance, as B is travelling to the ground, it's going to hit the ground, it's going to travel that distance. At that phase we want to calculate the acceleration, the tension and the velocity. Then as B hits the ground, we then want to calculate the acceleration for block A, because block B is now not pulling on it, it's now on its own with its own momentum that it's began with. And then the total distance that A has travelled for the whole of the journey. That's what we need. So first of all, calculate the acceleration and tension. That's going to be down to our forces. So use force equals mass times acceleration. So that's going to be our go-to equation to get us where we need. So let's have a look at what's happening at B first. That's going to be the most simple one. So at B, we've got the weight of the block pulling down with gravity, so that'd be 4mg. And pulling against it, the only force is going to be the tension in the string. So that'd be minus T. So the tension is going away from the direction of travel, so that's going to be a minus. And then we set that to mass times acceleration. So that's our forces. And we set it equal to mass times acceleration. Mass is 4m, so it equals 4ma. Okay, so now we need to look at what's going on at A. So A is a little bit different here. We're on the plane here, so our forces, we've got a little bit going in this direction and also a little bit from the normal force. So to calculate that, we need to create a little triangle here. So draw a perpendicular line from the block. Draw a line straight vertically down and then meet it here with a line parallel to the plane. Now if this angle is alpha, then this angle here will also be alpha. And then what we need to do now is resolve for this force and this force to give our total forces for this block. So if I call that force, or R, let's call it R1 and R2. So for R1, that's from that angle there with a right angle triangle, that's going to be using sine. And for R2, because it's adjacent, we'll be using cosine. Now the hypotenuse we will know because it's the force acting vertically downwards from this block, which will be 2mg. So that's 2mg. So now let's work out our forces. Well, going in the correct direction, we've got tension. So we can put a positive T in there. And then we'll subtract these two forces. So R1, so what is R1? So it's going to be sine equals opposite over hypotenuse. Now sine of alpha, we don't know too much about it just yet, but we know tangent alpha is 3/4. So let's draw a little triangle. A nice little right angle triangle, call that angle alpha. Now using Sokotawa, tangent alpha is 3/4, opposite over adjacent. Now from that we can work out the hypotenuse using Pythagoras' theorem. So the hypotenuse will be 5. So now we can work out our sine alpha and our cosine alphas from that. So then we've got, let's just have a look at what's going on for R1. So for R1, so sine of alpha equals R1 over 2mg. Okay, now sine of alpha we know will be 3/5, opposite over hypotenuse. So then we've got 3/5 equals R1 over 2mg. Now to get R1 its own, just multiply both sides by 2mg. So R1 is 6mg over 5, but it's going in the opposite direction of travel, so it's a negative. Okay, now let's resolve for force 2. So then we'll have cosine alpha equals R2 over 2mg. Okay, so we'll just work this bit out first and then we'll introduce the coefficient of friction. So cosine alpha, so that's going to be adjacent over hypotenuse, that's 4/5. Okay, now multiply both sides by 2mg, you get 8mg over 5. So let's just write that there. But now I need to multiply it by the coefficient of friction. I need to times that by mu. So mu is what? Mu is 0.25 or a quarter. So then it will have 8mg over 20. Which I can simplify, get it over 5, just the same as this one. So I get 2mg over 5. Now remember, this is also going in the opposite direction, so that's going to be a negative. So minus 2mg over 5. And then that's my forces taken care of. And set it equal to mass times acceleration. Mass is 2m. Okay, so now I've got a simultaneous equation situation. Unknown here and an unknown here. And what I can do is I can do the usual business on that, where I add the two equations together and then I can solve for A. So if I draw a line there, add them together, take this off the board, I can work out what's going on. Okay, so now let's add them together to eliminate t. So the t's will disappear. Now I'm left with 4mg minus 6mg over 5 minus 2mg over 5. So let's just work this out. 4mg minus 8mg over 5. So that's 4 minus 8/5. So that's going to leave me with 20/5, that's 12/5. So I've got 12/5 mg equals, add those together, 6ma. Okay, so now I can eliminate the m because I've got m in the equation on both sides. So eliminate that and then divide by 6. Divide that by 6. So I can put this on divide by 6, I'll just do 6 times 5 there. So then I'll have 12g over 30 equals A. So simplify this down, A will become 4/10 or 0.4. So A equals 0.4 and it's multiplied by G. Now I'm going to leave it like that. I'm not going to put in the 9.81 just yet. I'm just going to leave it as that. So acceleration is 0.4 g meters per second squared. And then with that, I can now calculate my tension. So let's use this top one there. So 4mg minus t equals 4ma. Bring the t over and bring this one over. So then t equals 4mg minus 4ma. So now I've got a 4m and a 4m common in both. So I've got 4mg minus a equals t. Now A, I know what A is, it's 0.4 g. So I've got 4mg minus 0.4 g equals t. Well, I've got 1g minus 0.4 g, so now I've got 0.6 g. So 4m times 0.6 g equals t. Well, I can just do now 4 times 0.6 is 2.4, and I've got an m and a g. So t equals 2.4 mg newtons. So that's my first two bits from my forces. Now we can calculate velocity because I've got my acceleration. Tension won't come into it for this because this here is things are happening, things are moving. So now we can use the Suvat equations. So if I write my Suvats, let's put them here. So S, U, V, A and T. What have I got and what do I need and what don't I need? That's what I need to do at this stage. So S is my distance. So in this stage, the distance travelled is going to be h. U is my initial velocity. So it's going to be starting from stationary. V is the velocity. Well, that's what I want to find. Acceleration, I've just calculated that. That's 0.4 g. And time, it doesn't ask me about time, so I'll just leave that in there as a blank. So I've got S, U, V, A, they're given as values, so I need an equation that's going to help me with that. So v squared equals u squared plus 2as. That looks like the one that springs to mind. Okay, v squared, that's what we want. And now I just plug in the values that I've got from my table of values here. U squared is 0, so that's just disappeared. I've got 2 times a times s. So I've got 2 times a, 0.4g, and times s, well h, that's the height that we're given in the question there. So then v squared equals 0.8 gh. So now if I take the square root of that, I can get v equals 2 root 5 gh over 5. That would give me my v on its own in sort of surd format. So that's my velocity. So I've got 2 root 5 gh all over 5. Now I'm going to keep my v squared because I might need that a little bit later. V squared equals 0.8 gh, so 4 gh over 5. Okay, so now we're into the second phase. So I'm going to clear this off and then we're going to have a look at question 4 and question 5. Okay, right, find the acceleration of A and find the total distance A has travelled, but that's after B hits the ground. So now the acceleration of the system is going to be changed because B is not going to be pulling the strings to make A move anymore. So A is now going on its own motion. So we need to recalculate what's going on here. So we're back to using our force equals mass times acceleration to find our new acceleration of the system. Now we don't have to go into too much detail because we did a bit of the work already to work out what's happening at A, but now the tension is not part of it. The tension is now gone, the string is not there. So we're just left with these now to solve for mass times acceleration. So now that's our forces. So I've got 8 mg over 5 equals 2 ma. So that's what I've got there. So now I just need to solve for A. So now divide both sides by 2m. So now I've got minus 8 mg, divide by 2m, so the A will be gone on its own, sorry. Then I'll have 2m times 5. So that's now going to give me 10m. So I've got minus 8m over 10m times g. So that's going to give me minus 4/5. So minus 4/5 g equals my new acceleration. So with that, we're now ready to try and work out our total distance travelled. So put that acceleration in there. So minus 4/5 times g. So you can plug in the 9.81 there, work that out for yourselves, but that's our representation there of our acceleration. Okay. Now let's find the total distance travelled. So we've got a couple of steps we need to do here. We now need to find the new velocity of the system like we did here. So let's be back to our v squared equals u squared plus 2as. So let's box those off. Let's write down our formula. And let's do our list of SUVAT components here. So SUVAT. Well, we know A, because that's our new calculation we did there. So that's minus 4/5 g. T, as before, we don't know what that is. Now, U and V, well, we have calculated V already, but it was the V as the system was moving. So now the V, when the system was moving, when B was falling to ground, that's now our initial velocity. So our initial velocity is going to be this. So I'm just going to put a little arrow to those so I don't have to write them out again. There's no point in me writing them out, they're just right there. Oh, actually that's V, I'll put that down as V, that should be my U. Let me just change that. That's my initial velocity. And then V is my velocity, that's going to be going to 0 because we want to know how far it travels, so it's going to eventually stop. So V is now 0. And S is the distance we need to find. Okay, so let's plug in here and see what we can solve for now. So v squared, well, that's going to be 0. U squared, well, that's now our old v squared, which is 4gh over 5. So luckily we kept that. That could be useful. And then plus 2 times acceleration times rs. Well, acceleration is negative, so I'm going to change that to a negative. So I've got minus 2 times 4/5 g. So that's my acceleration times 2. And s, that's what we need to find. That's our distance. Okay, let's bring this over to this side. So now I've got minus 4/5 gh equals minus 8g over 5. And that's s. Okay, so now what I need to do now, divide this side by the reciprocal of that to get s on its own. So if I write s equals, and then write that reciprocal, so minus 5 over 8g, so that's that reciprocal, times that, that should then give me my s. So there should be some nice simplifications here. So the 5's cancel. I've got minus times a minus, so they're gone, they can now be plus. I've got g and g, they can cancel. And I've got a 4 and an 8, so 4 over 8. So this here just becomes 4 over 8, which equals 1/2. So the distance travelled is going to be half of h. But that's only the distance when B has hit the floor. So I've got half of h. What's the total distance? Well, it would have travelled when B's fallen to the ground. This would have come with it, so it would have also travelled by h. So therefore I've got 3h over 2 as my total distance travelled. Okay, so that's quite a good question there, and that completes all of our calculations. Okay.